Hi guys, you're with Gusto. Today is International CFS Awareness Day, and I have the pleasure of being joined by Associate Professor Brett Lidbury. He's a biometrics researcher at ANU.
Biometric, that's part of it. Bioinformatics, more computational biology.
Right.
But all those things, biostatistics, machine learning, all sorts of funny algorithms, yes.
Right.
So we attack, maybe that's not the right word, but we come at problems through interrogating, enormous amounts of data where possible, and also rely on volunteers, which is wonderful. And actually, at the top of this interaction, I'd like to mention none of this would be possible without Don Lewis and his team at CFS Discovery in Don Vale, just out of Melbourne, and because that's the clinic we get these wonderful volunteers who give up their time so generously and control people as well, and. Big deal out to Edwina as well, who's the registered nurse who works with the patients and participants.
Yeah, thanks a lot to those folks.
Yes, I must right off the bat.
Absolutely. Well, and since we're offering personal, insights,
yes.
I'm also very happy to see that ANU is doing a lot of research, because I myself am an ANU alumni. Yep, I spent 4 years there getting my degree.
Well done.
Some of the best years of my life when I was fit and healthy, so
of course.
Yeah, I have a lot of good memories, and it's
a wonderful place.
It is.
In fact, I'm also alumni. I did my PhD at the ANU. Before that, I was undergraduate, did science honours at the University of Newcastle, so up the track, and so a good experience. Newcastle at the time was a small campus. ANU, of course, was littered with very famous scientists when I went there as a student. It was quite a great experience on many levels. Yeah,
it's a fantastic campus, and I love learning there.
Yeah,
so
wonderful.
So do you want to tell us a little bit about your background and how you arrived in the CFS space?
Yeah, happy to do so. I usually introduce myself as someone who's relatively new to the area. When I say that, I had my first conversation with Don Lewis, who's a medical practitioner and director of CFS Discovery. Our first conversation was in June 2009.
Right.
And flowing from that was funding from the Alison Hunter Memorial Foundation here in Sydney, and thanks to them.
Right.
And Christine Hunter, to get us underway. And it was just basically, if I can just give you the potted history of it, my background is as a virologist, and I did a lot of work previously on Ross River virus, which in the Australian context is one of the usual suspects that we talk about in terms of post-viral syndromes and fatigue. And back in sort of the noughties, around 2005 to 2010, I would regularly give talks on virology, particularly Ross River disease, at the Australian Science Festival held in Canberra, where I was based. And one thing led to another, and one year we were very lucky to have colleagues from Sydney come as well, so we broadened the usual virology talks about Ross River to involve ME as a condition associated with it. And through that, I was invited to some ACT seminars by the local support society within the ACT. And one day the phone rang, and it was actually Christine Hunter from the Alison Hunter Foundation.
Right. And
she put me in touch with Don, and it's been a great, love story, I was going to say, ever since, in terms of mutual admiration for each other and how we work together. So, Don's very, very forward-thinking, and quite an exception, I believe, to the rule when talking about the medical profession, unfortunately, dealing with ME. So, really, things really got underway in 2011. So I've only been actively researching ME since then. First publication was in, I have to think now, 2014, I think, and we've had two recently, which we can maybe touch on later.
Sure.
So it came through Virology, came in through the back door.
Yep.
And
here you are.
Here I am. Very compelling story to be had, about ME and what we could do.
Yeah, absolutely. And can you tell us what your current goals are for your present and future research?
Yes, I have them on two levels. At heart, I consider myself a fundamental biomedical researcher, so I'm really interested in really complicated stuff.
Okay.
So one part of me is using, and I'm not in the laboratory anymore, I've started in a lab, but I'm now fully computational and fully focused on human biology.
Yeah.
We don't develop any animal models at all in this work. So it's all based on that and the algorithms I mentioned before and the computational aspects. And through that, I'm very keen to actually find ways to investigate what we call pathogenesis, so disease processes like that very fundamental level.
Sounds very sci-fi.
Very sci-fi, really, to understand how this works, or doesn't work, as the case may be. You've got pathology, which is ME, and of course physiology, which is our normal functioning. So there's that question, but side by side with that, fortunately, is research which, I mean, the buzzword in medical research for about 10 years or so now has been translational research.
Okay.
And like anything that's relatively new, it takes a little while to pick up some momentum. So, but the other thing is, and having worked on ME and with clinicians for a while, I can see that part of the barrier, I think, for, I suppose, better access to expertise in the medical profession and health professions is that actually the criteria is inconsistent. I mean, there's, you know, now the international, there's a Fukuda, you know, which one do I choose?
Yep.
But there are commonalities between them. You know, how do we use pathology results? I mean, the part of the problem I'm sure you've experienced is they send off blood tests. Now, any patient walks in, we always do a suite of medical tests on blood.
Yeah, I feel like I've had my whole body weight in blood taken at various points.
Absolutely, and it's an amazing suite of tests that can be done that can tell you a lot about the functioning of the human body or a mammal's body in general. However, I know the experience is clinically the patients go through that process, the results come back, everything's normal. What that means is it's all within the reference interval that's used to guide clinical decision making. So, to summarise, I'll be going for hours, is side by side is to aim for the translational aspects of the work. So while in, you know, getting information
so
from
it's
patients,
pulling all the information from those tests into some sort of not common sense, but into some sort of sensical arrangement where you can pull insights from that.
And to look, rather than in a linear sense, at just a reference interval, which is still fantastic. I mean, there's nothing wrong with them. But when you've got something so mysterious like ME, we're looking, you know, I'll sound a little bit sci-fi. We're looking in higher dimensions, a bit like Star Trek.
I like it.
Yeah, and we're looking at modelling the data and looking for patterns within how things actually interact. So rather than looking, you know, you can take a few tests together and make a decision, but we're looking at all the very basic information that a regular GP would look at in assessing a patient, and looking at the patterns and trying to simplify not just the blood test parameters, but also the aspects of the clinical criteria that are used. And of course, Don Lewis uses the international criteria, and in fact, he was, an advisor to the upgrade. I mean that in the nicest possible way, but the change from the Canadian to the international criteria.
Right.
But there's a lot of information to get through. So how can we really drill down and find, for screening, it may not be the full examination, but how can we help medical practitioners find the really basic things that within 15 or 20 minutes in their surgery they can see and say, oh, there is something wrong. Let's send you off to somebody who knows, who can do deeper investigation. So to basically provide tools to medical practitioners in the community to actually make a quicker assessment and not be overwhelmed by information.
So it's essentially a biomarker, but it sounds like it's a biomarker drawing from a number of sources. Is that
absolutely?
Is that right? Okay, that sounds fantastic. And you mentioned you take a non-animal approach to your research. Can you explain how that differs from traditional biomedical research?
Yes, you still hear it quite a lot nowadays, and I come from an animal research background and have published many papers, particularly I mentioned before the Ross River disease. And with Australian and US collaborators, we've done some, I think, really good work on understanding what you'd call pathogenesis, again, disease processes, you know, in infection, but in a mouse model particularly. And of course, there's a full range of you know, different genetic types and breeds of mice and things. I formally moved away from that area. So it would have been around about the time I started thinking about ME research, probably 2009, 2010. And I haven't done any animal work now, well, since 2007 in fact, when I was involved in an honours project. So scientifically, particularly the inbred rodent models, particularly mice, are very enticing because you can reduce variables. You can compare say, one mouse with another mouse, or
they're very genetically pure in a way.
They're pure. Yeah, they're genetically identical, and then of course you can do some genetic engineering and make a whole lot of mice which are deficient in a particular gene, or they're more robust in a particular genetic sense. So in terms of traditional science, reducing variables and really getting to the core of an argument or a problem, you know, they do fit very well. However, you know, it's the 21st century, and in spite of all those advantages, you have about 60 million years of divergent evolution between rodents and primates like ourselves.
That's a good point.
And so you've got this species barrier. So with, you know, 10, 20, you know, we always say 10, 20 years ago, but in fairly recent time, the sort of questions we wanted to ask were really only accessible through animal models, but things have changed so much, particularly in the omics areas, proteomics, transcriptomics, genomics, of course. And there's our environmental eco-omics, and, you know, looking in a broader sense within a system, there's so many great techniques that the disadvantages we had in doing human-based research, which has always been valuable anyway, particularly clinical trial, you know, as a fundamental researcher, we can now tap into those types of that sort of progress and advances in the field and look directly at the human biology, and thus by doing that actually remove 60 million years of divergent evolution.
Yeah, that's handy.
Which is handy, and of course we've still got the problem of variation, you know, because we can't control what humans eat, where they live, you know, those sorts of things.
Yeah.
However, you know, we're scientists, this is what we're about, you know, dealing with these problems.
And do you think that all research is going to take that sort of direction in the future, or is there a role for both animal and non-animal? I
think at this stage, animal-based research in biomedicine won't go away anytime soon. Although there is a growing literature indicating that the translation rate from what we call our preclinical, like our discovering preclinical animal phase, the translation through to human benefit is actually quite poor.
Right.
And there might be other reasons for that in terms of practice and other things, which I won't get into. However, in saying that, animal models have contributed to our insights, and what we need to do is, while moving towards, myself and colleagues in the Netherlands, for example, are very keen to talk about, and others, you know, outside of these two countries, we're starting to talk about innovative human-focused research, which is predicated entirely on a philosophy called the 3 R's, which was something written about in the late 1950s by Russell and Birch. And those 3 R's for animal research are replacement, reduction and refinement.
Okay.
We do refinement very well, but we still need to move towards the other part of the philosophical foundation for this, to both, if we must use animals, use them as effectively as possible and make sure the results are as reliable as possible. And where possible, actually replace the need for an animal entirely, and just really go to the source. And again, as I alluded to, the technology there, and, you know, the great great progress thanks to colleagues around the world is there to utilise. But there may be still a small percentage, maybe 5 to 10% of animal models that might still provide some value. I'm not convinced personally that an animal model of ME would add any value.
Okay.
I'm actually currently, with my Dutch colleagues, doing an analysis of the literature of the past 30 odd years on that to see what we can find. But the thinking still today is, to understand human disease, we must have an animal model. But we're slowly moving away from that.
Yeah. Moving into the 21st century, it sounds like a little bit.
That's what I like to do. Yeah.
Excellent. Now, using vast amounts of data and mining them for insights is very much in the zeitgeist at the moment,
sure.
Especially with Facebook and Cambridge Analytica scandals happening. But thankfully, you're using those capabilities for good. So can you offer some insight into how that process is done and how all that massive amounts of data are required?
Yeah, there's sort of two sides to this. I'm also I'm self-funded, so I have a few balls in the air at the moment, and they do converge around things like ME. But the other thing I'm associated with, I'm actually been recently made or entered or permitted to be a fellow of the Royal College of Pathology here in Australia and New Zealand, as a fellow of their Faculty of Science. And just by mentioning that, of course, to do that, I've got to have, or you must have a strong interest in laboratory medicine.
Right.
So those blood tests we talked about before. So that sort of modelling. So part of it is we can get through partnerships with a laboratory in Queensland, and through the actual college here, which is based in Sydney, and other colleagues who work in diagnostics and in the pathology industry. We can, with the correct permissions and ethics, we can get access to enormous databases.
Right.
And it's interesting, in biology and biomedicine, a big database is maybe 2,000 cases. A really big one, 25, you might get up to a few 100,000. Talk to an astronomer or an engineer or climatologist, of course, that's small.
Yeah.
But for us, when I started learning this, our sample sizes were 5 to 10, cell cultures or maybe animals. So we can get access through partnering with pathologists or pathology labs or the health departments to get hold of. And I should mention at this stage, I'm doing work through what's called the Quality Use of Pathology program, which is run by the Department of Health, the federal department in Canberra. So that sort of work really helps, because it helps me learn and my colleagues learn how to interrogate this massive data and to get patterns or derive or find patterns of use, which, as I mentioned before, will help us over CFS, and we can find patterns which are simpler to, they're more sophisticated but simpler to apply, because it'll show something different. Whereas the problem at the moment is that blood tests show that there's nothing different to what you call a healthy person. So,
it sounds like there's a lot of multivariable analysis
this
sort of thing.
That's exactly right. And that's what you must do with humans because of that variation issue. And some of us in this more academic research field are thinking, well, normally people like myself think of variation as a problem, because we want to know what it is, the one thing.
You want to narrow it down, sure.
But now we're starting to think, well, how can we make variation an advantage?
Right, I like it.
So at the deepest philosophical sort of point of what it is to be a scientist in this field, you've got to swap your brain around and think about, well, what's the variation telling us? And in fact, there's now statisticians and others saying, well, let's get more interested in outliers. Whereas normally we just sort of push them to one side and think, it makes it...
Let's bring everyone into the fold.
Let's do it. Let's understand the range of experience and see what patterns we can discover, which through the new machine learning, particularly approaches that we use, is possible.
Right.
Okay. And that's in hand with statistics and other things we can do computationally. So, however, for the ME work specifically, because of funding and people's time and other constraints, when you work with actual people, not just their data, that's being put into a database, which is all anonymous, by the way, and
everyone's safe. It's okay.
Everyone's safe. Yeah, we don't know anything about anyone except the blood test. But with the ME, it's different, because say we have 100 participants in a study, and of which a number of them, maybe 20 or more of them, are healthy controls. So we might have, say, 70 to 80 people who are ME. Right. And when I say that, they fulfil the international criteria according to Don Lewis and his team that I mentioned. So we have those people. So we don't have the thousands and thousands. Fortunately, though, thanks to very clever statisticians, computer scientists, we have various algorithms which we can do something called bootstrapping. So we can take a smallish sample and we can actually run it many, even thousands of times to actually, from a small sample, look for broader patterns.
So is that like an extrapolation methodology?
Yeah, it's like a sort of an extrapolation or interpolation, where you're looking for trends which you can then... And of course the great thing is, being that the clinical tests and the pathology tests are relatively simple routine procedures, we can look at patterns and then we can go back to the health practitioners and say, well, here's a pattern, here it is.
Can we investigate this further?
Can you look at it and see if we can validate it? And if not, we have to go back and rethink it.
There you go.
So we can work very closely with the clinical staff in, it might be a pattern of blood test results, survey or questionnaire data, anything that we can do like that.
Yeah, that sounds great. And so does all that data, it sounds like it comes from various sources. It's not just, a single organisation pulling this stuff together. Is that right? Not just ANU, essentially. There's multiple labs. Is that...
That's right.
Right.
Lead partners. We, of course, have, and in the CFS discovery context, if it's a first consultation, the appointment might run from 2 to 3 hours.
Right.
All the baseline data is collected, and then people come for follow-up, months afterwards. So you have the very what we call nominal data. It's yes or no, black or white. So you've got that very basic clinical data which can be put into what I call a data matrix. Mm-hmm. And then, of course, pathology testing, which will go off to a pathology lab.
Right.
And in our research budgets, we put in an amount of money to pay the clinic to see a patient. Can't do it under Medicare because it's research. Right. So we pay the clinic out of research funds. Mm-hmm. And all this again, I can assure you, ethical approval, sure. Anonymous, all those things, and patients have consented.
Excellent.
Or we call them participants, it's research. Mm-hmm. But then, as part of that workup, they have blood collected in the clinic and that's sent to a pathology provider. And we pay them as well to do pathology just like anyone would. Because again, they can't claim it under Medicare. Sure. So what happens is, over time, what we have is the really fundamental part, which is where I work with, and I should mention my friend and colleague, Dr. Alice Richardson, who's our chief statistician, and also with NCEPH at the ANU. We've worked closely on this for some time, and she's the one who really, has developed and encouraged this approach, and she's taught me how to do the coding and the rest. So absolutely critical to be multidisciplinary. But what happens then is we get the basic data. So the patient comes, they do what's called a standing test, yep. Which we've actually just published.
It's like a POTS sort of test, is it?
It's an interesting thing. The first paper we published actually with a former student, Gemma Reynolds, showed actually the POTS comorbidity. And I read things around saying, well, it's all POTS or it's not. But actually part of the work, and it's been done by Julia Newton's group in Northern England as well, is with this test for orthostatic intolerance, POTS, in our estimation, and it was amazing how close we got. From our study, we estimated, and this was a retrospective study on records that were collected from previous patients, again anonymously, etc. Yeah. 11% of the cohort within that sample that was provided had comorbid POTS. Right. So they fulfilled the criteria for ME, mm-hmm. but also that 11% had POTS.
Yeah, I know some patients with that, yeah.
So the other 90%, 89% presumably didn't. They just had ME mm-hmm. by the definitions we used. Sure. Now what was fascinating, looking at the various blood pressure, heart rate, sort of what we call autonomic parameters, was you could separate. So we had 300 cases versus about 30 or 40, not a great match, but by just looking at these two cohorts, there were some trends that appeared. For example, the POTS comorbidity seemed to appear in younger patients.
Ah, okay.
And POTS, by definition, is post-orthostatic tachycardia syndrome. Yep. So our cutoff was a heart rate jump of 30 beats a minute or more. Mm-hmm. So we were seeing that primarily in younger patients with a shorter illness.
Interesting.
Yeah, rather than older people. And where the cutoff is for older, I haven't quite looked at yet, but people in their 20s, for example, or teenage years, are more likely, from our analysis, to have comorbid POTS. Uh-huh. So it does complicate things somewhat.
Yep. And so how does that relate, I guess, back to the research? Does that just, are you saying it sort of contaminates it a little bit, or it's just an interesting result that you found?
It's great to have it. It's great to have basically as much data as we can get. Mm-hmm. So what we can do now is actually make, in our data matrix that I mentioned, we just have a code for a participant. Mm-hmm. Now we just have these big lists and we have data, and we can just basically add into the matrix POTS yes or no.
Right.
Okay, and we can then, when we do the modelling later, to actually find the patterns that I talked about, we can put that into the model and account for it.
Right, so they become essentially another variable that you can account for.
Exactly right.
Okay.
Yes, indeed.
Brilliant. Do you tend to meet many sufferers like me in your interactions, or is it just mainly through the data?
Being an academic in the ivory tower, I mean, my day-to-day work is with the data.
Sure.
But I have made it a priority to keep in touch with people experiencing ME. Yeah. And people who support them as much as I can. For example, the events of today.
Today, yeah.
Being the 12th of May. And I'm actually here in Sydney to support the local event. So, in fact, I see, and it's something I'll talk about in a little bit more depth in the future, but I see there's a lot of power, and in terms of translational research, I can sort of see I've talked already about the interaction between the ivory tower academic sorts like myself, who are really focused on the hardcore research, the clinic, but of course then you've got the community around that.
Yeah.
And because we're taking a multivariable approach, I'm interested in stories. In fact, nowadays we can do what's called text mining. It's nothing that I've done for this project as yet, but it would be really interesting to hear more in like an anthropological sense, people's stories, and get a feel, and also realise that the community, the patients, their families, are also experts. That's not normally seen, of course, in...
Yeah, we're forced to be by virtue of the lack of support, so...
You live with it. You're the expert, not me, not you, whatever medical practitioners treating you. We know what we do, they know in the clinic. Yeah,
and so the idea is to build a little bit of the... the story behind the data into the data.
Absolutely.
A little bit. Yeah, I think that's fantastic.
And how to do that, I'm not exactly sure yet, but it's certainly of great interest.
Yeah, no, that sounds fantastic. And are you able to share any interesting insights from your current research, or did you already cover that?
No, I've talked, I've been a little bit selfish. I've talked really, it was all about me. I'm talking about what we do. But of course, and I've prefaced this already, because the nature of ME is multi-systems and multi-physiological system is what I mean. You just can't really do it alone. Now, I have this great constellation of collaborators around me. And in fact, I'll start with what's potentially a very exciting piece of work, which I've done in collaboration with Paranta Biosciences, which is a company interested in a protein called activin.
Okay.
And we have published 2 papers in the last 2 years looking at many things, but one of those papers particularly highlighted the potential, and I emphasise potential, of activin B, which is there's 3 members of this protein family, which acts as what we call a cytokine, it's part of the language of the immune system and the other parts of physiology. So there's activin A, B, and a binding protein called follistatin. So we've been looking in collaboration with Paranta, but also with Mark Hedger and his team at the Hudson Institute, and David Kretzer, who was the real push in this area of activin some time ago and who's recently retired. So the Monash, Hudson and Paranta and the activin, and we're looking forward to seeing, because we have published our preliminary findings on this, and part of the current study, which will finish later this year, is about looking to validate to see if we find the same in a different population.
Sure. So is that essentially using those 3 markers as a potential biomarker? Did I read that
correct?
Correctly?
Yes.
Right.
And of course, what we hope is that in time, with the correct validation. And I've been very lucky too with, again, Dutch colleagues to actually have some samples from the Netherlands.
Right.
So wouldn't it be amazing if we found the same patterns in Dutch patients as we did in Australia, given the geographical distance. But those results are still coming. But we've published some work from our preliminary studies on that. So we've got that immune function, like the immune biomarker, which has been looked at a lot in the last 25 years. I should also mention part of the constellation is Professor Paul Fisher and his team at La Trobe University, the Mundura campus in North Melbourne. They're doing some amazing stuff on mitochondrial function, which you read a bit about. So the mitochondria are what are called organelles. They're little machines inside of your cell which generate what's called ATP, the energy to keep us going. And it makes sense on so many levels. It's an energy efficiency. And Paul and his team, Daniel and Sarah and others, are doing some amazing experiments at the moment looking at
a biomarker inside the mitochondria.
Inside the mitochondrial compartment. And just moving along, connected to Paul and a group that's been working in CFS for quite some time, or MECFS, sorry. Also Paul Gooley, Chris Armstrong at Bio21, which is attached to the University of Melbourne, more from the metabolomics point of view. So they're really interested in, it's not something you can measure easily in a pathology lab, but through the various spectrometries like mass spec and HPLC and other really
expensive machines.
Big expensive machines that are amazing. They've actually looked at patterns again of where particularly amino acids and other sort of markers look not quite right, and they've published a little bit on that.
Right.
I can't remember exactly what they found.
No, that's all right. But it sounds like we're getting closer by virtue of
we're working together.
A number of organisations.
Absolutely. So these are the people I work with on a regular basis and communicate with regularly. And that's not the whole picture. There's, of course, other work going on in Queensland with Sonia Marshall, Gradisnik and Don Staines on more, immune cells and calcium channels and such like.
Well.
So there's quite a bit going on in Australia, and if I've forgotten to mention other people's research, I apologise, but they're people I'm most familiar with.
Yeah, it's just fantastic to hear there's such a massive network of collaborators at the moment, a lot of smart people
absolutely
putting their minds to it, so I think that's really fantastic. Hopefully there's some more, definitive biomarkers and a definitive test coming out soon, but it sounds like we're getting closer. So do you think ME/CFS will be found to be like one specific disease or a multitude of sub-illnesses? I know you mentioned POTS, it sounds like almost a sub-illness.
Yeah, you could, in a very broad sense, you could, particularly now that we understand that the association with age, you could then say, well, yes, we now have two cohorts. We have ME only, and we have ME POTS, for example. So you've now what we call stratified.
Right.
My view is, and this is just my view, and I'll be happy to be wrong in future, but my sense is that ME will be something akin to autism. It'll be a spectrum.
Right, yeah.
And one of the big questions at the moment that we really need to understand is what kicked off the disease process.
Sure.
Like we spoke earlier about.
I told him a little bit about how I first got the flu when I got sick, and then I was mild, then I turned moderate, and then I turned severe, and now I'm moderate.
Yeah. And actually, just if I ask you a question, when you were severe, were you 24 hours a day bedbound?
No, I was housebound, so I could move around the house.
Get out of the house.
But I couldn't speak. So
wow.
Yeah.
Wow.
It was extremely difficult. Yeah.
And to think somebody that sick has normal pathology tests, it's quite astounding. And of course, as I mentioned, we're working, our own work is focusing on that really basic data. We can do more with it. So, I really feel that we'll find in the fullness of time that there might be different triggers. The other one's heavy metal exposure, which has been mentioned, in various conversations and publications on ME. A viral trigger, which is probably more, which unfortunately has led to your situation, and maybe something else we don't know about. And that will be a first excellent clue. And also the genetics associated with that, and I've been waiting for this moment to mention too, I have two really close friends and colleagues who were with me at the ANU but have both moved back to their homes in South America.
Right.
That's Mauricio Arcos-Burgos and Claudio Mastronardi. And with them we've got funding also to do some genetics. So, and what I envisage in future as an ongoing contribution to understanding is maybe to look at genetic profiles as well in that systems approach, to sort of say, well, are there any patterns in terms of, and they don't have to be what we learned at school as mutations,
right,
but they might just be various genetic markers.
Yeah.
And
just sort of a predisposition in a way.
A predisposition, exactly. Do we find,
something.
even at a ancestry level, there was, I haven't heard it much lately, but when I first came into the field, there was people proposing what they call the Whitening Hypothesis.
Right.
The people with a Northern European ethnicity or a strong.
Yes, I have heard that.
Yeah.
I saw very briefly, and I'm not an expert in reading studies, but there was a note that I read that it seems to affect primarily Anglo types.
Yeah, it does.
Yeah.
And when you think about, say the Vikings, I mean, they were good travellers, they got around, and so Viking genes, in inverted commas, I mean, certainly are in Australia through, of course, European migration, and of course, the New World in general, the US, New Zealand, Canada, etc., where we see it. So just those sorts of questions will be fascinating in our cohort or our sample. And because anything else physiologically that we pick up.
And genetics, that's a whole nother area of gigantic information. I mean, I've seen the physical books that they put together of one person's genetic code. So that sounds like a massive treasure trove to get into at some point.
In my virology days, I used to carry, in hard copy, believe it or not, a folder of the Ross River virus genome, which is just a minuscule fraction of the human genome. It used to be that thick.
Yeah.
I'd have to go through it with a pen and pencil.
No,
and a ruler, and that was just one virus with a 11 kilobase genome. I mean, it's phenomenal.
Yeah, it sounds like the machines are really going to have to save us on that one.
The machines, that's the only thing that.
Yeah.
Otherwise, there'll be someone like me, just like the monks used to transcribe the Bible. Someone sitting in a monastery for their entire life, sort of going through. And of course, we can do it much more quickly.
Yeah. And you have researchers with you whose sole job it is essentially is to wrangle that data and try and pull out the insights. Is that
That's
accurate?
what we do at the ANU. So Alice and myself and our students, when we're lucky enough to have students, that's what we really focus on.
That is your job.
Data wrangling is what we do.
Right.
Yeah. So I spend a lot of my time in front of the computer. I'm still an experimentalist at heart because that's my background. But yeah, I run experiments now rather than a lab. I do it in silico. And of course, Alice is a PhD in statistics, and we use statistical modelling to take this diffuse variable data and again detect the patterns.
Yeah.
And my colleagues that I mentioned provide data from their laboratories, and we can integrate that into our systems biology matrix, I suppose we could call it, to then see how and make predictions about how much, say, a gene function or a protein might, contribute.
Yeah, and hopefully you'll pull out a piece of the puzzle that goes into the greater puzzle that is ME/CFS.
Absolutely.
So that's fascinating. And how do you think we can get more researchers involved in ME/CFS, or do you think funding is the primary restriction?
There's two things there, and in fact I said, I think before our formal interview now, and certainly to Mary from Shark Island last night, I try as much as I can to avoid the F word, funding, right? But you just can't. And colleagues have actually put together some compelling statistics on the amount of funding going towards ME, CFS, and for chronic fatigue broadly in Australia versus other, very important health conditions.
Yeah, I dedicated a whole episode of my vlog to that question,
That question, and it's minuscule. So the first thing is, there's actually three things. Funding. Well, someone look at that, well, why would I go into that? It's very unlikely I'll get funding.
As a researcher, it's just not a valid career path if you can't see any career there.
And also, unfortunately, I think within the research community where, in fact, I've read editorials in journals and, all over the place, people saying, no, this is a real disease. So only in the last probably 4 or 5 years, the researchers, or some anyway, saying, no, this is real, let's get into it. And of course, I take my hat off to people who've been doing research for longer, in spite of the fact that it's remained controversial is what I'm looking for. So again, a prospective researcher or clinician or a physiotherapist, health professional or academic will look at it and go, well, it's still, which way do I go? I'm not sure which criteria do we use, which way do we go, and will it be career limiting? People have been given career, don't work on this, it'll be career limiting. Because of funding, but also the lack of, I suppose, it sounds funny for a research, but certainty in understanding.
Researchers face the same, career uncertainties as every other job, especially when, it seems like a very nebulous network of funding if it's not coming from the government in a strong stream. So
that's right.
Do you think that funding is the main?
I think so.
Attractor.
It'd be in the top, definitely in the top two.
And the other one would just be
the controversy and just the uncertainty and the sort of, I suppose, advice that maybe people give that it's so tricky. And on the funding, I should say here in Australia that it wasn't for the Judith Mason Foundation and the Alison Hunter Memorial Foundation I mentioned before. Apart from that very small, comparatively small amount of funding from the NHMRC, which has historically been shown, there'd be essentially no funding.
That's almost entirely how your work is funded. So from sufferers like me, and I'm sure I'm going to speak on behalf of a lot of sufferers, we really thank those foundations for the important contributions they're making to your research. And
I should actually, before we go on, I should also give a pitch too, and there's been a lot of pitches through this, but you've got to recognise the brave people, whether they're researchers or advocates like yourself or funding bodies, but also ME Research UK, based in Scotland, has very generously provided some support for the genetic study with Mauricio Macordia. So, the drive there, normally, understandably, a foundation in a particular country will only fund research within that country. But this one, they're happy to support work, so we're very lucky to have that. But
that's terrific.
That is terrific.
That's my Scottish accent. My Scottish, thank you.
I won't try.
I'm just being silly, but no, that's definitely appreciated that we've
really
been
is.
able to.
And it came out of the blue. It's just, again, serendipity plays a large role.
That's fantastic. Yeah, we need a lot more serendipity, I think. So,
absolutely.
Final question is, what is one thing that you think people should know about ME/CFS?
Yeah, one thing is, it's ME, Millions Missing Day. ME is real. It's not in people's heads. Now, of course, by having the disease will clearly affect your mood and things, but don't conflate them. What I'm seeing in my own research and the research of my collaborators, there are physiological, biochemical things going wrong, and it's real, and the people who are sick aren't making it up. The people are sick, believe them, talk to them, validate them. They're not making it up.
Yeah, I couldn't agree more. Well, Dr. Lidbury, let me say this slowly. Dr. Lidbury, I believe you are expected at a Q&A of a local unrest screening as part of the Missing Millions, as part of the Millions Missing campaign. So a huge thank you today for your time and your dedication to our cause, and I look forward to more research coming out of your lab soon. So
look forward to talking again.
It's been a pleasure. Thank you.
Pleasure.